So just a quick introduction. My name is Martin Kopp. I'm the Division Engineering Manager for the Hydraulic and Industrial Process Filtration Division of Europe, Middle East and Africa. I'm actually a chemical engineer. I've spent 33 years working in the oil and gas and petrochemicals markets. I've been involved in lots of different aspects: product design, product management, sales. I'm very heavily involved in the Gas Processors Association for Europe, which I'm a director of, and I've also been, or had the honour of being the chairperson for 2 years. One of the other things I'm also doing for Parker is I'm leading the development of the gas water alkaline separators, and also we have an integration project we're looking at to find ways to reduce the parasitic energy demand of electrolyzers. So the agenda for today, so first of all I'll give you a quick introduction to the Parker Filtration Group. Then we're going to have a little look at the different challenges for filtration and cooling within the electrolyzers. And then we're going to have a little bit of a look at the refueling stations and the same sort of challenges. So just a quick introduction to the filtration group. So filtration group is a group within Parker that consists of 18 separate divisions globally. The product portfolio is basically split into 4 main platforms. So we've got what we call the engine and mobile platform, and in that area we have filtration for liquid fuels, primarily diesel, so that's particulate and water separation. We also have filtration solutions for crankcase ventilation, so that's basically removing oil mists from gas being ventilated from a crankcase. Then we have engine air intake filtration, and we have some other specialist filtration technologies. The next platform we have is what we call the hydraulics and lube. So within the hydraulics and lube filtration, we have low, medium and high pressure hydraulic filtration. We also have contaminant measurement technology, so that we can measure the amount of contaminant and the quantity of contaminant within lube oils and hydraulic oil streams. And that can also be ferrous wear metals as well. We also have single and duplex filtration systems that we do for heavy lubrication oil and also for larger volumes of diesel and heavy fuel oil on marine engines and large 2-stroke and 4-stroke engines. Next segment that we have is what we call the industrial air and gas segment. So within that segment we have things like compressed air dryers, we will have compressed air filtration, we have nitrogen generation, so this is generating nitrogen from air using a variety of technologies, primarily a hollow fibre membrane type approach. We then have air intake filtration for large gas turbines and large industrial engines. We also have a range of HVAC, so heating, ventilation, air conditioning filtration as well. And then the last thing that we do is we have some dryers and deoxo technology that we can use for natural gas and obviously also hydrogen. And then the last platform that we have is what we call the process liquids and water, and then also the cooling side of things. So within that platform we have a range of chillers, we have a range of gas coolers and gas heat exchangers, we have a range of gas coalescers and gas filtration equipment, we have a range of liquid filtration and liquid coalescing technology. So as you can see from the Parker portfolio, we have a very wide range of technologies available, and what that does is it allows us to offer solutions that will go from the primary energy production right the way through to the point of use. So if we look at the energy source, we've got technologies that are suitable and are used widely in fossil fuel production, in biogas production, and also in renewable energy, so in wind turbines and photovoltaics. And then we also have technology that is suitable for hydrogen production, so whether that's steam reforming of natural gas in either a grey format or a blue. Obviously the difference between blue and grey is that within the blue you actually capture the carbon on the back end. And then we also have technology that is used in the electrolyzers, so that we can actually treat all of the required contaminants and purify all of the required streams that need to go into an electrolyzer. And that's where we're going to talk a lot more detail about. From a distribution standpoint, we have technology that will be used in compressors. We have technology that is used in refueling and storage systems. And then when we come to the end use, we've got technology that will be used in engines, motive power generation, electricity power generation, industrial uses, and also in domestic, HVAC type applications. What we're going to talk about here mainly is going to be the technologies that we've got in electrolyzers and refueling stations. I'm not going to touch too much on the hydrogen fuel cell or the transportation. That's been dealt with in another one of these breakout sessions. So let's go to the filtration solutions for electrolyzers. So as you can see from this slide, we've actually got technology that can be used in all areas of the hydrogen production using an electrolyzer. So at the front end we've got the feed water production or preparation. So within there we've got a range of water purification technology, which we'll talk a little bit more detail about in a minute. Once you actually get into the stack itself, we've got technology that will be able to separate water or lye droplets from the produced gas, so from the hydrogen and the oxygen. We also have nitrogen generators that will be able to inert the system to make sure that during a shutdown, for example, that there is no explosive environments that are going to cause any problems when you open things up. And then also we have, mainly for the alkali electrolyzer, we have a range of lye filtration technology that we can offer. And then when we get to the purification side of things, we've got obviously the nitrogen generators that we already talked about, again for the inerting, but we've also got some deoxo and dryer solutions specifically for hydrogen. That is under development at the moment. We're pretty close to getting that finalized and launched. So as you can see, we've got a lot of different areas that we work with on an electrolyzer. One of the things that we are also working on, and I mentioned at the start that we were looking at the reduction of parasitic energy demand, we're actually looking at ways to combine different areas from the system to reduce any energy input into the system. And what we're looking at doing, for example, is being able to recover heat from cooling systems or from the gas liquid separators and utilize that heat to optimize the drying system, the deoxo system, and also the nitrogen generation side of it. So that's something that we're working on. We're quite well advanced in that. We've got a lot of ideas that we've created, and we're in the process of development further and testing. When we talk about electrolyzer, this here is just showing a containerized electrolyzer solution. It's generic, it's not specific to any one company. We are aware that obviously a lot of the electrolyzer applications we're coming across at the moment will not be containerized. This tends to be for the smaller megawatt production units, but you know, we presenting it this way as a way to show it in a more easy manner. So what can we do here? Well, obviously we've got the inerted nitrogen gas generator, we've got the liquid filtration and the demineralization and the reverse osmosis here, and obviously lye filtration would come up there. We've got the chillers and the coolers for keeping the system cool and operating at the right temperature. We've got the gas purification for the absorption, dryer and the deoxos. We've got the water separators, which would come downstream of the stacks. And then we also have a range of condition monitoring equipment that we're looking at utilising in this area. So when we start talking about the demin water production, Parker have been involved in this market space for quite some period of time. So we've got over 40 years experience in water purification. That's primarily been in the oil and gas markets, where we've been producing drinking water for the rigs, or pure water for use in the processes where you can't use seawater. But we've also got products that we use in, for example, in the military, in the navies, to actually purify seawater for drinking. That's used in industrial cruise ships and things like that as well. So the systems are configurable, and the system design will actually depend upon the raw water source that would be used for the electrolyzer. They might consist of, well, they will always consist of particle filtration. There will always be a level of filtration up front. But then when we start going into the actual ultra pure water generation, you might have activated carbon filters, there might be ion exchange for preconditioning, there might be softeners, there might be some specialty resins, there might be some chemical injection and mixing systems that need to be added upstream before we go into the actual reverse osmosis. So you might need reverse osmosis, you might need electrodeionization, you might need combined systems of RO and EDI to get to the water purity that you need. So as a company, we're able to offer the full system from pure water, the raw water intake to very, very high quality water treatment at the back end. I mentioned that we have live filtration, so we have a range of liquid filters that we can use. This is one of the ones we've been looking at using a lot. It's what we call an extreme pure. It uses large diameter 6-inch in-out filters. One of the reasons that we want to look at using that is that all of the contaminant is kept within the filter element, so that when you take the filter element out, none of the contaminant can pass into the clean downstream side of the filter vessel and then cause contamination within the lye downstream and get that into the stack, which obviously can have a big impact on the efficiency and the throughput of the stack itself. We then have the separators. The separator technology that we're talking about is based on a very well proven technology that we have. We have a technology called the Gemini PureRecep, which is a multi-stage horizontal coalescer. With that technology, we can get liquid contaminant levels in the treated gas in single parts per billion level, so very, very pure gas. This technology allows us to recover as much of the water that's been produced, or the lye that's been produced, at quite some considerable cost, and it allows us to recover as much of that as possible and add it back into the system, so that you're not wasting any water that otherwise, or lye that otherwise you would be generating hydrogen from. It also creates or protects downstream equipment such as compressors. It can also protect downstream equipment such as the deoxo, which doesn't like any water or liquid droplets going into it, and also the dryers. So by using this technology, we can actually have a very, very good energy efficiency, or improve the energy efficiency of the electrolyzer. Moving on to the chillers, we have a range of chillers. The chillers will get up to about 700 kilowatts. It says 360 kilowatts there. We do have options to get up to 700 kilowatts. Then we also have heat exchangers and gas coolers that will do a wide variety of applications. We have one specific technology, which is a very unique technology, which we call a printed circuit heat exchanger. And that printed circuit heat exchanger technology is very well proven in applications up to 1000 bar. It actually has no seals on it, so there's no gaskets to leak. So it's also in an electrolyzer application where you've got very flammable gases. such as oxygen and hydrogen, it's a very good technology from a safety perspective, as you don't have any gaskets that could potentially leak. This is being used at the moment in some of the deoxo dryer systems that we're looking at, and also we're talking to other people about using it as a downstream cooler from on the back end of compression trains, or even as a cooler from an exit from a high pressure electrolyzer stack. And then we come to the gas purification, drying and deoxo section. So, sorry, excuse me for that. We have a wide range of technologies. We've got 40 years experience of supplying dryers into compressed air and compressed natural gas applications. We are in development of a hydrogen specific dryer. There are a little bit, some small differences between hydrogen and other gases, which mean that we're in a testing phase at the moment on the dryer, just to make sure that we get the performance that we expect. Lab tests have shown that we are getting purities down to -70 dew point on the treated hydrogen. So, you know, we are able to hit most of the specs that are out there on the hydrogen dryness, hydrogen purity. And as I say, one of the things that we're working on is a combination dryer deoxo, where we can utilize the exothermic energy that's coming out of the deoxo to support on the drying. So we've got some solutions that we're in the process of developing there. And then when we look at the nitrogen gas generators, we've got a wide variety there. The nitrogen gas, the generation technology, like I said, is primarily based around hollow fiber membranes. It's a pressure swing absorption technology as well. So we have pressure swing absorption technology as well as the membrane technology, and this is generally used to provide nitrogen that we can inert the systems with. So as I mentioned earlier, one of the things that we are looking at is the utilization, is the integration of the system, and as you can see from this visual here, from this slide, we do have technologies that will operate across all of the areas that you need on an electrolyzer from a filtration and purification section. The key now is for us to find a way to integrate these as much as possible to reduce the amount of parasitic energy. So the amount of energy that you're putting into the system that isn't producing hydrogen through the electrolysis, we're now identifying ways to link this equipment together so that we can reduce that amount of electricity consumption as much as possible. So when we come to refueling stations, I have actually the slide, there isn't too much of a slide on there, but we do have filtration and cooling solutions for the refueling stations. So you've already seen the chillers. The chillers will be able to be used on the refueling stations, and the gas filtration, so the compressed gas filtration that we showed earlier on, that can also be used in the refueling stations. Thank you for the attendance. I'm going to close down the session. Thank you very much.